Hello everyone, welcome to the new session on projection of solids, that is projection of pyramids. That is, we are starting with session 4 on projection of solids. Projection. Now, this problem 8 in this session 4, what it describes is this is a pentagonal pyramid of base sides 25 and height 50 has one of its base corners on HP with its axis inclined at 40 degrees to HP and top of the axis is inclined at 45 degrees to VP. Draw projections of this pentagonal pyramid in this position, base is nearer to the observer. Now, what you do is draw pentagon A, B, C, D, E. You have 5 edges. Okay, and once you have written the pentagonal pyramid, you have to locate the apex. Draw perpendicular bisector from any two sides, and the intersection of these the perpendicular bisector of any two sides will give the apex point. That is the axis point OO1. Now you join OA, OB, OC, OD, OE. In that way, you will have 10 edges. You should remember that it's a pentagonal pyramid which will have 10 edges. You have to manage 10 edges throughout. And when this pentagonal pyramid is rotated with respect to HP and VP, for an observer who is looking from the top direction and front direction and all that, some of the edges will be visible, some of the edges will be invisible. You have to take care of all those steps. Now, pentagonal pyramid top view is over. Now, take the height as 50 and join the outer boundary and all that. And now you see here. This is A, B, C, D, E I have written. This is O bracket, O1 is the axis. Since B is nearer, B dash bracket A dash. Since C is nearer, C dash bracket D dash. This D is here, this is D dash. And O dash, O dash is the axis. Now count the number of edges. Since it is a base here, it is a 5 edges here. Plus 2 edges here, that is 2 slant edges overlapping, OB and OA. 2 slant edges here overlapping, and plus 1 slant edge here. 5, 2, 2 and 1, totally amounting to 10 edges. Now we must know that tilting left will be edge on HP, tilting right will be corner on HP. Now what I'll do is, I've tilted right such that it is corner on HP. As in the problem, I've tilted in such a way that axis is inclined at 40 degrees to HP. In the solid edge, what you do is, this is move, copy and rotate in such a way that the axis is inclined at 40 degree or base is inclined at 50 degrees to HP. Now in this position, you have to write the top view. Now we are looking from here. The step number 1 says obtain all the points and join the outer boundary. Then I have got all the points here. That is A here, B here. Okay, C and D on these lines. C here, E line, and D here, O here. In that way, outer boundary I have drawn. Now, since apex is nearer than the base, remaining edges of the base should be dotted. Okay, in that way, immediately I'll make ED and DC dotted. Okay, now you count the number of edges. 5 plus 2, 7 edges are over. You are left with only 3 edges, OA, OB and OD. Now as you see here, when you are looking from here at the top, OB and OA, these two slant edges are nearer to the observer. As a result, you can see in the top view, and this OD, which is far away edge, when you are looking from there, this is blocked by the solid. This edge cannot be seen by the observer, hence OD will make it dotted. In that way, OA and OB, which are near edges, I have darkened it. OD, which is far away, I made it dotted. Show the axis. Axis you show, and as you know, axis is not an edge, it is just an axis of symmetry. You can show the axis only between D and O1. Change the line type, D to O1, one big one dot line, you show only between D and O1. O to D it's an invisible edge. Okay, O to D is an invisible edge, and D to O1 is axis representation. Actually, the axis is between O and O1. Now, the problem says is, the top of the axis is inclined at 45 degrees to VP. In that way, what you do is, This is again as usual, move, copy and rotate it such that the axis O1 is inclined at 45 degrees to VP. Now, as usual, take all the points to the other view and you are expected to write the front view here. First step is join the outer boundary of these points. Once you join the outer boundary of these points, the step 1 is completed. In the step 2, compare apex with the base. If you observe here, base is nearer than the apex. For an observer who is looking from front direction, base can be seen. Hence, I'll darken the base. Now you count the number of edges, 5 plus 2, 7 edges over. And 3 more edges are there. One is OB, one is OA, one is OD. If OB, if you say, if the B is the nearer corner edge, O dash, B dash should be darkened in the view. And O dash, E dash and O dash, D dash, they are the back corner edges. As a result, it cannot be seen. Hence, we will make it dot dotted. And finally, take the projector from the O1, projector from O1 and show the axis. That completes problem 8. Now coming to the problem 9. Problem 9, initially it is same as problem 8. You start in the same way. Pentagonal pyramid you write, writing by perpendicular bisector and all that, getting O1 and all that. A, B, C, D, E, 5 edges. OA, OB, OC, OD, OE, another 5, 10 edges. Get the front view. This is 50 mm. In that way, this is 5 edges, 2 edges here, 2 slant edges merging one against the other, 2 edges here, and 1 slant edge totally amounting to 10 edges. 5, 2 slant edges, 2 slant edges, 1 slant edges, 1 slant edge, 10 edge. Now, if you see here, in the previous problem, I tilted right such that it was corner on HP. Now, I am tilting left so that edge is on HP. Edge B dash, A dash is on HP, and I have moved and copied and rotated in such a way that axis is inclined at 40 degrees to HP. Okay. Once it is in this 40, that is when the axis is inclined at 40 degrees to HP, when you are looking from the top, how it appears in the top view has to be drawn. Now, what you do, get all the points and as usual, join the outer boundary of these points. Now, as you know very well, apex was nearer than the base. They have enlarged the view here. Remaining edges of the base should be dot dotted. That means E to A to B and B to C should be dot dotted. Okay. Now, if you observe here, E to A to B, B to C should be invisible. Now, we are left with 3 more edges. And if you see, OD will be nearer edge, which will be darkened. OE, OA and OB will be faraway edges. Hence, it will be made dot dotted. Now, you see here, OD is nearer edge, you darken it. And OA and OB, that is these 2 slant edges, when you are looking from here, cannot be seen. OB and OA, that will be made dot dotted. Since it is all very close, you can zoom the area and see whether it is okay or not. Okay, I have seen, you see here, I have zoomed the area, OA and OB, I have made it dot dotted. They are the invisible edges. Now the question says, the edge on HP, the edge on HP is AB. That should be inclined at 30 degrees to VP. Okay, that is why what I will do is, edge on HP inclined at 30 degrees to VP, that is, move, copy and rotate in such a way that is, edge on HP is inclined at 30 degrees to VP. In this position, what you do, you have to get the front view. Now, even here, you have to be very close. You should know what exactly is happening here. Here, you are looking from here. You are looking from here. You should know the step number 1 anyway is the outer boundary. Once you draw the outer boundary, since base is nearer, you have to darken the base. You enlarge the area, carefully you do it. It has been deliberately planned so that you should not get confused here. Now the first step is do the outer boundary. It is O dash to D dash, D dash, E dash, E dash, A dash, A dash, B dash, and B dash to dash is the outer boundary. Since base is nearer, darken the base. Okay, once you darken the base, you are left with only three edges. O dash, C dash, O dash, E dash, and O dash, A dash. O dash, C dash, since C is nearer, you darken O dash, C dash. And O dash, E dash, and O dash, A dash, they are faraway edges. As a result, cannot be seen by the observer. See here, O dash, C dash have darkened it, and O dash, E dash, and O dash, A dash, they are the back edges when you are looking from here. There is O dash, E dash, and O dash, E dash, A dash. When you are looking from here, this E and A back edges cannot be seen by the observer, hence you make it dark dotted. Okay, and finally show the axis. In that way, this problem gets completed. Now the problem 10 says, problem 10 says, a pentagonal pyramid of base sides 25 and height 50 has one of its slant edges on HP. Draw the projections of this pentagonal pyramid when the slant edge on HP is inclined at 45 degrees to VP. Okay, assume base is nearer to the observer. Now, draw the pentagonal pyramid in the usual way. Draw the top view, draw the front view. I have told you what exactly is the procedure, you do it. Now, if you see here, tilting completely right will be O dash D dash on XY line. That means slant edge on HP. Tilting completely left, it will be triangular surface on HP. Now what you want is in problem 10, slant edge on HP. That is why I completely tilt right. Now if I completely tilt right, slant edge will be on HP. Okay. Once it is in this way, I have to write the top view, take all the points to the other view, join the outer boundary of these points. When you are looking from the top, base is exposed. That is, apex base is nearer than the apex. Since base is exposed when the observer is looking from here, complete base you can see. That's why darken the base. Now in that way, if you count the number of edges after the second step, 5 plus 2, 7 over. Then you are left with OA, OB and OD. OA and OB, when you are looking from here, OA and OB are nearer, darken it. And OD is far away edge, make it dark dotted because it is the OD, it is a slant edge on which it is resting. Obviously, an observer who is looking from the top to get the top view, when it is resting on OD itself, he cannot see the edge on which it is resting. Hence, O dash or O to D will be invisible. And show the axis. And axis is between O and O1. Don't prefer axis to slant edge. That is an invisible edge. O to D dark dotted only you see. This axis is merged with this invisible edge OD. Now, what exactly is happening here is the top view of the axis is inclined at 45 degrees to VP, or you can even say this edge on HP is inclined at 45 degrees to VP because edge on HP is O dash D dash, that is OD. If you observe here, since it is on HP, OD is in true length. That is why edge on HP is slant edge. If that slant edge is inclined at 45 degrees to HP, it is same as telling top view of the axis inclined at 45 degrees because the axis is not in true length. But slant edge OC is in true length. Okay, that is why slant edge on HP is inclined at 45 degrees to VP means you do this way. And okay, to get the front view, take the projectors to the front, join the outer boundary. Since base is nearer, darken the base, and OC is nearer, darken OC, and O dash A dash and O dash E dash are far away edges, make it dark dotted, and finally show the axis. In that way, you are completing the problem number 10. Thanks for watching.